So, we've all seen it. Large language models, right? They're changing the game for how we write code, turning a simple sentence into actual software in seconds. It feels like magic, but here's the thing. There's a real danger hidden in that magic. Without a plan, you're not conjuring a solution. You're conjuring a mess.
And this is the tightrope we're all walking. On one side, you've got this incredible promise. You say, hey, create an order service for me. And bam, there it is. But on the other side, there's the peril. What you usually get is this giant tangled up class that's a nightmare to test and even worse to maintain. And that's not just annoying. That's how projects die, buried under technical debt. So the big question is, how do we get all that speed without creating a monster?
Well, the answer starts with one of the most fundamental ideas in all of software design: abstraction. This is our #1 tool for taming the chaos that an LLM can create if you just let it run wild.
The best way to get your head around this is to think of abstraction as a user interface for something really, really complex. Think about driving a car. All you need are the pedals and a steering wheel. You don't need to know a thing about how the engine works to get to the grocery store. That's a beautiful abstraction right there.
Okay, so let's put a slightly more formal pin in it. An abstraction is basically a conceptual filter. Its whole job is to simplify a system by hiding all the messy, complicated stuff under the hood and only showing you the essential controls you actually need to use it.
And here's what that looks like in the real world, in your code. Without abstraction, you get this ugly situation where your user interface code is directly fiddling with database queries. It becomes this tangled, fragile mess. But with abstraction, you create a clean separation, something like a customer repository interface. It acts like a wall, totally separating the UI from the database, which makes your code flexible, strong, and way, way easier to test.
And that idea of a clean wall, well, that takes us right to our next big concept, which builds right on top of abstraction, and that's boundaries. If abstractions simplify things, boundaries create stable, predictable agreements inside your software.
You know, this quote from the source material just nails it. It says, "Boundaries function as explicit contracts. They meticulously define what external components can reliably depend upon." The key word there is contract. This isn't just a suggestion. It's a formal agreement between the different parts of your system.
And the perfect analogy for this, I love this one, is a simple electrical outlet. Think about it. First, it defines the contract. 2 prongs, a specific voltage. It's a stable, predictable standard. Second, it hides the implementation. You have no idea if that power is coming from a nuclear plant or a solar farm, and you don't care. And third, that standard enables total freedom and innovation. Anyone can go out and build a toaster or a TV, knowing it'll just plug in and work. That's the power of a strong boundary.
So what happens when those boundaries break down? You get what the developer Joel Spolsky famously called leaky abstractions. And you've probably seen the symptoms. Your responsibilities get all tangled up. Logging code is mixed in with your core business rules. Error handling starts bleeding all over the place. You get these massive God objects, these classes that try to do absolutely everything. It's a maintenance nightmare, plain and simple.
So all of this leads to a completely new way of thinking about our relationship with AI. It's not about being replaced. It's about a new kind of partnership, the architect and the builder.
In this partnership, the LLM is your tireless builder. It's unbelievably good at the how. It can churn out all the implementation details, all the boilerplate code, and connect the dots faster and more accurately than any human ever could. And that means your role has to evolve. You become the software architect. Your irreplaceable value, the thing that keeps you essential, is defining the what. You design the blueprints, you set the abstractions, and you enforce the boundaries that guide that builder.
A developer who really embraced this shift put it perfectly. He said, "My primary role wasn't to handcraft every line of logic. It was to sculpt and enforce the architectural boundaries." See, the job becomes more strategic. It's all about design.
All right, let's make this really concrete. We're going to walk through a quick case study, building an order processing system.
So, without boundaries, if you just tell your LLM, make an order service, you're going to get a monster. A single giant class with business logic, database calls, API stuff, all of it mashed together. You touch one thing, and the whole system crumbles. But with boundaries, you do it differently. You first define separate contracts, like an order repository interface and a payment gateway interface. That protects your core business logic and makes the whole thing incredibly resilient.
It really is just like designing a house. The boundaries are the walls. They create separate rooms. You've got a kitchen for cooking and a bathroom for, well, plumbing. And because they're separate, you can fix a leaky pipe in the bathroom without having to tear down your living room walls. It is the exact same principle in good software.
And here's the best part.
You don't have to make this stuff up from scratch. There are proven, battle-tested architectural patterns out there, like ports and adapters or clean architecture. These are basically just recipes for creating those strong boundaries. You can use these patterns as the blueprints you feed to your LLM.
So how do you actually put this into practice? Okay, step 1. Be super explicit in your prompts. Don't just say, build a service. Say, define a user repository interface with these specific methods. Step 2, and this is a great trick, have the LLM generate the tests first for the interface. Then tell it to write the code to make those tests pass. And step 3, work iteratively. Define your interfaces, then the implementations, then the services that use them. It's a much cleaner process.
So let's bring it all home and talk about what this means for you, for your role as a developer in this new world.
Let's be crystal clear about where this is all heading. LLMs are becoming the undisputed masters of implementation. The how of coding, the boilerplate, the plumbing, that's their game now, and they're only getting better.
Which means your value, your irreplaceable value, is moving up the stack. It's in design, it's in architecture. You are the one who defines the what. You're the visionary, the strategist with the blueprint.
And I want to leave you with this one line that just perfectly captures this new reality. Your role as a developer is to set the seams, then let the LLM weave the fabric. You create the pattern, the AI does the detailed stitching. It's a powerful partnership.
And that leads to one final, really exciting question to think about. As AI takes on more and more of the tedious grunt work, freeing you up to focus on that high-level design, what great systems will you design?